Hello there. Today we're going to talk about future-proofing your applications with modular design and how to avoid getting slimed by the, quote, big ball of mud. So my name is Eric Murphy. I'm an architect for Red Hat Consulting that specializes in building modern applications for OpenShift. I have great experience modernizing legacy applications as well as building MVPs for startup companies. I enjoy the fast pace of designing and building applications for Red Hat OpenShift using DevOps and Agile methodologies. And I'm also leading a new team, the App Dev Center of Excellence here at Red Hat.
And my name is Aleš Nosek. I'm a container application architect within Red Hat Services team, and I'm focused on helping customers to architect and build cloud and container native applications. I'm passionate about open source emerging technologies as well as DevOps culture. And if you are interested, I maintain a blog where I provide best practices and patterns which I learn about. And you can find the blog at alešnosek.com.
So for today's discussion, we're going to discuss modular application architecture and applying modularity to both monoliths and microservices. This gives you a future-proof modular design for any architecture. Also, Aleš is going to demo a simple application modeled after Instagram that contains photos and likes features and is architected around modular principles. He's also going to do a code walkthrough and a demo. So first, let's talk about the big ball of mud. So according to Brian Foote and Joseph Yoder, a big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and baling wire spaghetti code jungle. These systems show unmistakable signs of unregulated growth and repeated expedient repair. Information is shared promiscuously among distant elements of the system, often to the point where nearly all important information becomes global or duplicated. So, how do you avoid creating big balls of mud? Well, you need to think about application modularity and flavors of application modularity. So we're proposing 5 flavors of application modularity, with the first 4 being, number 1, source control modularity, where you utilize multiple Git repositories for one large application. This allows you to scale your application development across teams, and this is known as programming in the large. Number 2 is build modularity, where you build separate projects and publish artifacts to a repository such as Nexus. In Java, you may use Maven modules or Gradle projects for building discrete application components. The third flavor of modularity would be code modularity, where you can emit and listen for events to facilitate cross-module communication, and you don't call another module's code directly. There's also separation of API from implementation code, and you could also use Java modules to provide granular contractual guarantees during compile time. The fourth flavor is data modularity, where you do not create tight coupling of data between modules, such as sharing a database schema. So, in building applications, these 4 flavors of modularity can apply to both monoliths and microservice architecture. And for building large applications, you should aim to apply all of these 4 flavors. So, could there be an additional flavor of modularity that only applies to microservices? The answer is yes, and the 5th flavor of modularity is for deployments, where you are deploying multiple microservices or functions instead of one application. And this may also involve partitioning your data into separate deployed databases rather than sharing a database between multiple microservices. Also, this would require inter-service rather than intra-service communication, where you propagate events between services using a network transport. Additionally, user interfaces or clients must utilize multiple services, potentially through an API aggregator. So how do you avoid getting slimed by the big ball of mud? Well, you must strongly enforce source control modularity, build modularity, code modularity, data modularity, and deployment modularity for microservices. And so many people associate big balls of mud with monolithic applications, but trust me, you can create big balls of mud for microservice applications as well. So some food for thought. What are the major differences in code that would exist between a strictly modular monolithic application and an equivalent microservice implementation? We'll come back to this later.